Good morning, afternoon, or evening, wherever and whenever you are. My name is Ben, and welcome to this Godot perfect pixel art platformer series. This series is made possible by all of the wonderful people who have supported me by purchasing my 1-bit Godot course. And I want to announce that it was recently updated and is currently on sale. So you can check out the link in the the description or the comments below and the end of this video if you're interested in that. So in the last episode, we made a character that can move around and jump and has gravity and collides with these blocks. Like this, we set up a scene for our world, for our character, and for the blocks as well. In this episode, we're going to be refining our platformer a bit because the current controls don't feel that good. So first, let's start with, let's do some basic acceleration and deceleration for our character, so some friction. And we're going to set this up by, at the start of our physics process here, we're actually going to start making some functions too. And the reason we're going to do this is it will help us organize our code better. So let's have a function called apply gravity. Okay, and we can just copy this code right here and paste it down here and then replace it with apply gravity. This makes our code much more readable. We don't have to guess what this line does. We get a function here that gives us a clear indication of what the line does because of its name. Okay, and now we're going to get the, what I like to call the x input. So we're going to say var x input. Well, you can also just do input equals vector2.0. So this is going to be a vector that contains the input for our character's movement. And we can say input.x is equal to input.isAction pressed UI right minus input.isAction pressed UI left. Now what does this line do? It gets a number, which is going to be a number between -1 and 1. So it'll be either -1, 0, or 1. That's going to be what this will output, and it will depend on which arrow keys, left or right, the player is pressing. So if they're pressing the right key and not the left, then this is going to be 1, and this is going to be 0, and that's going to be 1 minus 0, which is 0. If they're pressing the left key but not the right, then this is going to be 0, and this is going to be 1. And 0 minus 1 is -1. So it's going to give us a -1 if we want to move to the left, a 0 if we don't want to move at all. If they're both 1 or they're both 0, we'll get 0. And then a +1 if we want to move to the right. Now it's telling us that these operands, bool and bool, cannot be subtracted. And that's because these actually don't return 1. They return either true or false. Now we could convert them into a 1 or a 0 by doing bool at the start here. But we can also use another function in Godot, which is getActionStrength. And this can be useful if you're going to have controller support, because then it might not just be 1, it might be 0.5 if their analog stick is only halfway over. And so we can use input.getActionStrength here and use that same one here. And now it's not going to freak out because this is actually going to be a number between 0 and 1, and we can subtract numbers like that. Okay? So we got our input.x. Now all we have to do is determine whether or not we need to move, to start moving or accelerating, or start stopping. Now if our input.x is equal to 0, we need to start stopping. And so let's create some functions here, we'll have one called apply friction. And in this function, we can just do pass for now. And we'll just say if input.x is equal to 0, apply friction. Did I spell that right? It looks weird. Okay, I think I did. Oh, I forgot to do if. That's why it's mad at me. If input.x is equal to 0, apply friction. Else, we're going to apply acceleration, I guess. And then we need to tell it which direction to apply the acceleration in, and we can do that just by passing in input.x. Okay, so let's make another function down here. Function apply acceleration. And then we'll pass in an amount or an input x, I guess. And we'll just do pass for now. Okay, so acceleration, let's see. I did this as input underscore x here, but I'm worried that's going to be confusing. This is its own variable. It's different from this. So maybe we'll just call this amount for now. That way it's hopefully a little less confusing. Okay, so now we can actually get rid of this line right here because that is what controlled our character's movement. And we can now fill out these functions right here and the logic inside of them. So let's start with applying acceleration. Now we can say, I see that in, we can manipulate our velocity in here. So we'll start by saying velocity dot x equals velocity dot x, no, equals move toward velocity dot x. Okay, so this is a from, so move toward is a handy little function where you can move a number towards another number. And it's really useful for applying acceleration and applying friction, because if we want to move towards a like 0, for example, but not go past it, go into negative or whatever, and you also don't know which side of 0 you're on, it doesn't matter. You can just move towards 0 and the function will handle it for you, which is really nice. So we're going to move towards 0. Well, in this case, we're going to move towards the maximum speed because we're accelerating, not applying a friction. But we want to move towards, what did we have our speed at before? 50, I think. So we want to move towards 50 times amount. So why are we timesing it by amount? Well, it's because we might want to move towards negative 50. So if amount is -1, that means we want to go to the left, which means we want to accelerate towards negative 50. But if amount is 1, then we want to go to the right, and so we want to accelerate towards 50, right? And now we need to tell it by how much we want to move. And this is going to be our acceleration value. And we're also going to multiply, we don't need to multiply the acceleration value by amount to be negative or positive. Okay, so we can just do our acceleration value, because Godot is going to take this number and it's going to move towards whatever the target is by this number. So if the target is -50 and our number is 2, it's going to subtract 2. If our target is positive 50 and the number is 2, it's going to add 2. Now, having a quick acceleration is pretty good usually. So I'm going to do something like 20 here, and we can see how that feels. Okay, so now we have our apply acceleration function working, and we can actually run the game to make sure. And you can see this does work. It's pretty snappy, but there's no friction. So let's do our friction. It's going to be very similar, only instead of approaching -50 or 50, we're going to approach 0. So velocity dot x equals move toward velocity dot x. So that's the from value. So we're starting here. We're moving towards 0, and we need to give it an amount. Now you can do your friction higher or lower than your acceleration if you want. I'm going to do the exact same number for now. And there we go. Now we should test just to make sure that this is actually working. Let's do a really low friction and a really low acceleration so we can be certain that it's working. And you can see that that is working. It's very, very slidey. And 20 actually felt a little too quick for me. I'm going to set it to 15 and see how that feels. But this is a number that you can tweak yourself. Whoa, that's pretty quick still, but you know. One thing that a lot of people will do is give you less acceleration and less friction depending on whether or not you're in the air. And that's kind of up to you. Well, I'm going to set these to 10 and just kind of make it, I want it to be the same, just to keep things simple. That feels pretty good. It feels smooth. Now we've currently got this frame locked, if you remember, in the last video. Delta is always the same number, but if we did have a very laggy computer, then this would be, our current numbers here are locked to the frame rate. Godot's frame rate in the physics process is locked to 60 frames per second when calculating physics. So it's not as big of a deal how we're doing this right now and not applying delta. But that's kind of something that's up to you if you want your game to be frame locked at 60 frames per second like this, or if you want to apply delta and deal with the math that's involved there. But it's in this case, it's not actually that bad to just lock it, have it tied to the frame rate here. So we're going to, now that we've done our slight acceleration and deceleration, we're going to worry about a variable jump height. This is another thing that can really help. So currently, we're saying if up is pressed, then we're setting our velocity, which funnily enough, some of you probably figured this out, but we have multiple jumps in the air because we're never actually checking if we're on the ground. Right? So there's a really easy way to check if you're on the ground inside of Godot, and it's using the kinematic body. So now if we look at our move and slide function here, so I just clicked on, you can hold control and click kinematic body 2D. You can come down to move and slide, click on that, and this gives us a description of the function in the documentation. You can see there is an up direction, and if we look at what up direction means here, it says up direction is the up direction used to determine what is a wall and what is a floor or what is a ceiling. If set to the default value of vector 2 0.0, everything is considered a wall. This is useful for top-down games. But for us, we're doing a platformer, so setting an up direction is actually useful because then we'll be able to take advantage of these functions like is on ceiling, is on floor, and is on wall. So we can just come down to where we're doing move and slide, and we can do a comma here, and we can pass in vector 2.up, and this will be our up direction. Now we can detect whether or not we're on the floor using an is on floor function. So if is on floor and input.is action just pressed UI up. So this should only allow us to jump if we're on the floor. And you can see that now works. We can't jump when we're on the ground, or in the air, I mean. Okay, but let's actually move this check right here inside of this function. So instead of combining these two with an and, we're actually going to do two if statements, and we can do that by doing a colon here, coming in, and then doing if, and then doing a tab in here. Now the reason I want to do that is because we want to have an else case right here. So if we're on the floor, let us press the jump button in order to jump. Else, if we're not on the floor, we want to do another check. This is for the variable jump height. If input dot is action just released UI up. So now we can check to see if we've released the up key, and we can set our velocity dot y equal to 0. Now this is going to cause some problems, but this will give us a start, and I'll show you that. Okay, now we have a variable jump height depending on when we release it. But it's really awkward when you release it on the way down because you suddenly stop. It's also really awkward to release it super soon. Usually you want to force them to go like a certain height, right? So they can't immediately release it and just barely jump. It's kind of awkward. So let's fix the first problem. So fixing the first problem about not being able to stop our velocity when we're on the way down is really easy. We can just say and velocity dot y is less than 0. Okay? Now this is because if our velocity dot y is less than 0, that means we're going up. And if our velocity dot y is greater than 0, that means we're going down. So you can see now we can't suddenly stop on the way back down, but we can still control our variable jump height on the way up, like this. So now what I like to do here is actually instead of doing just less than 0, we can also take our velocity here, like minus 120, which is what we set it to. And we can, instead of setting our velocity to 0, we can set it to a small amount, or an amount relative to where our velocity currently is. So so let's just try that. So let's say we set this to negative 30, for example. Okay. Now we can say, okay, if we immediately let off, we still kind of jump a little bit, and it looks less awkward because we can't jump less than negative 30. And if we hold it, then we can jump all the way. But there's a problem here, which is that if we hold it and then release right before our velocity is 0, well, yeah, there it was. We can get a little bit of a boost at the top of the jump. So instead of doing if velocity is less than 0, you can do if velocity is less than negative 30. Now, we shouldn't be able to get that boost at the top, at the apex of our jump, if we release just with perfect timing. And it's because if our velocity is less than negative 30, so if it's like 0, for example, then it won't let us get this last little bit of boost. And we don't need to cancel our jump at that point anyways, because we're pretty much at the top of the jump. But if we're at like negative 60, no. If we're greater than negative 30, so if we're like at, did I do this wrong? That's hard to remember. I can't seem to get the extra jump boost, but let's try setting this number to something higher, like 60. I want to make sure that I did this right, because sometimes the math here can be weird. Actually, negative 60 is a better number anyways, in my opinion, for this height. Maybe even a little higher, so that the minimum jumps up to the first block, and then like a maximum would jump up 2 blocks. But yeah, we did get the math right. So let's do like 130 and 64 maybe, like this. And this will give us kind of like our minimum will jump up onto this block like this. Not quite. And then our maximum can also, oh yeah, the maximum can barely make it up 2 blocks. So That's working pretty good. We'll do 70. 70 and 130. Perfect. Okay, so now we've implemented a variable jump height. Now another thing that is great to do is to implement a slight fast fall. A lot of platformers like Celeste will give you a jump that is kind of floaty on the way up, but then faster on the way down, because it's annoying to the player to sit and watch as their character slowly falls. So we can do this by saying, we can create a variable up at the top called var fastFell. And we'll do an underscore. And this can be a Boolean, so it's either true or false. We'll set this equal to false. So it always starts out as false. Now, if we're in the air, right, and we hit the apex of our jump, and then we start on the way back down, we want to apply a force that sends us down to the ground a little faster. So we can say if velocity dot y. Now, we might not want to do it right at 0. So we'll do if velocity.y is greater than maybe 10. So what that means is we've already started to fall just a little bit. So our velocity is now 10, not 0. 0 is right at the apex. And now our velocity is 10, which means we've started to fall. Gravity has been applied. How much is our gravity? 4. So gravity has been applied for 3 frames basically, and fast fell, and not fast fell. So we haven't applied a fast fall yet. Then we can say velocity dot y plus equals 20, maybe 25. I don't know. We'll have to experiment with what feels good. And fast fell equals true. Okay, this will make sure that it doesn't constantly apply this added velocity. And we can see how this looks. It doesn't work very good. Let's try increasing this by a large amount, making it like 60. It worked at the start, but it doesn't work on the way down, at least very well. Let's make it like 500. I'm not sure if this code is actually working correctly. Yeah. Oh, I know why. It's because fast fell is now equal to true and we never set it back to false. So we want to set it back to false whenever we land on the ground. So fast fell equals false. Okay, so that's why it wasn't working. 500 is going to be way too much. Now you can see we've got a little bit of a faster fall right near the apex of the jump. And maybe it would work best at 0. It feels a little bit weird not being at 0. Yeah. I do think that works pretty well. Now the other way that you could do this is just remove this and then just do velocity.y plus equals 2 or something. And that just means our gravity would be 4 on the way up and then 4 plus 2 on the way back down. So, that actually feels pretty good. Both of these work. One of them's easier than the other one because we can remove this whole fast fell variable out of the equation. So I think I'm going to go with the easier one. And you could even double gravity on the way back down if you wanted. Yeah, that feels pretty good. That does. I like that. And all of these numbers you're going to want to tweak for whatever style of game you're making, obviously. Okay. Now we've made a lot of what are called magic numbers, and that's all these numbers, which means you look at these and you have no clue what they actually mean. And like if we think about it, we know that this is actually our jump release height. This is our jump height. This is our acceleration. This is our max speed. No, this is friction. This is max speed. This is acceleration. But we need to make some variables for these so that they're no longer magic numbers, so that we can have some context for them. Now, there's two ways you can do this. One of them is just doing a const like this and saying, let's start with jump height, jump force equals negative 130. Okay? So then we could come down here and we can do jump force. Now we no longer have that magic number. And using constants is a pretty good way to do it. But I actually prefer using what Godot calls export variables. So we can do an export variable here instead. So we can say export. Now with an export variable, you have to tell it what kind of variable it is. And we're going to say this one's an int. We'll call it jump force, just like we did before. And we can set it to negative 130, just like we did before. We got to put var in here in between. I messed up. So there we go. Export, and then we tell it that it's an integer, which is just a number. And then var jump force. Now, the benefit of this is if we come into our player, we can actually manipulate this number right here in the editor and change it while the game is running. So let's say we're like, oh, you know, our character still doesn't jump quite high enough. It feels like it's really hard to make this jump. Okay, so, okay, well then we can lower this number down to 140. And then you can come back in here, and now the character more easily can make that jump. So you can manipulate the number in the editor and have it immediately reflect in game. And if we close this, it's going to keep that new value that we found. So this can be really good for tweaking variables, which is especially useful when you have a platformer and you're trying to get your numbers just right. It'll allow you to tweak them right here in the editor instead of messing with them in code. So we're going to do that with all of our variables. We're going to say export int var release jump force, jump release force. That's probably good. We'll do this minus 70 and replace it here. Jump release force. We can put that here too. There we go. Okay. And then we can do export int var max speed. These numbers are in pixels per step per frame, by the way, per physics frame. Max speed, what did we set our max speed to? 50 equals 50. And come down here. Max speed. And then we can separate our acceleration and friction if you want, even though they're the same number. Acceleration equals 10 and export int var friction equals 10, right? So then we can say acceleration or friction here and acceleration here. Now we have our gravity, export int var gravity. We'll set that to 4 and export int var additional fall gravity, I guess. And that's equal to 4 as well, right? We have both those set to 4 because we doubled it. Additional, did I spell that right? Okay, here's our gravity and here's our additional fall gravity. And there we go. Now we no longer have any weird magic numbers. This is kind of, I mean, we have 0 here and 0 here. This could be like, or 0 here. But I think in those cases, 0 makes quite a bit of sense. You could try to come up with variable names for each of them if you wanted to. So now we have an amazing platformer character that has a nice extra added fall to the gravity, so it comes down pretty quick. I actually feel like I want the falls, the jump release to be less. So -35, we'll do half. Like I thought I wanted it to be able to go to able to go on the first block, but I actually don't like it. And the additional gravity might be too much, and the normal gravity might be too little. Let's try something like that. Now we have to increase our jump height in order to make it. But this does feel better to me. It feels snappier. Our max speed is pretty slow. Let's try something like 75. I don't have to stop the game and run it. It's just, yeah, we're getting snappy. Now we'll get, I did it again, -160. Now we can make that jump. Yeah, this feels pretty good to me now. Some other things that you could do is a buffer, an input buffer, which allows them to immediately jump after hitting the ground. A cheap way to do this is just to change your jump pressed to just a from action just pressed to action pressed. That allows them to hold the key and immediately bounce again if they're holding it. Yeah, this feels good. This feels pretty good. Now you can also do Coyote Jump, which is a timer that allows you to jump for a certain amount of frames. We're not going to go into that into this video, but we might actually add it later in the series. But we're getting pretty late here. We're 32 minutes into this video. So I just want to thank you all so much for watching this video. It's been a good one. And I think we've learned a lot, made a lot of progress with the controls in our platformer and how it feels to move around in this world. In the next video, we'll probably be covering some basic animation stuff for our character and maybe some tile set stuff as well. Maybe I'll split that into 2 videos, I'm not sure. But thank you all so much for watching. If you like this type of content, be sure to subscribe and like it. If you're interested in my full Godot course, check out the description and the comment section for the link to that cell. And I will talk to you all later.